So yeah, as Ivan said, I'm David, one of the founders of Mapsi Photonics and the CEO of the company. We created it in 2021 with the aim of designing and manufacturing infrared filters and windows for infrared applications. Our focus is in industrial applications as well. Among many applications that we have, we are targeting the process monitoring, gas monitoring, and surveillance of industrial plants. We do it with a special technology, disruptive and patented technology, that basically what we do is we have simplified the way how filters and windows are done. Instead of adding layers over substrate, germanium, silicon, one over another, what we have done is to simplify it, as I was saying, and we only drill the substrate. In our case, it's just silicon. And by controlling the shape of the holes that we drill and the length, we are able to increase the resolution if we are talking about filters, especially when we are going to the long infrared region. And also we have a high quality and mechanical characteristics of our filters and windows, because we are only using silicon, and it melts, for example, only in 1100 degrees. Also, we save costs and energy because we are using electrochemical process, and we avoid the intensive use of electricity, for example, as it is done in conventional technology. Also, we avoid the use of critical materials like germanium that are restricted geographically. As I was saying, the products that Mapsi we market are bandpass filters in the whole infrared region, from the middle wave infrared to the long wave infrared. We have narrow bandpass filters, broad bandpass filters, windows. Also in here, we are going from 1 micron to 14 microns, and neutral density filters. And regarding the new product that we are today presenting, we are presenting the macroporous silicon windows that go from 3 to 5, that are specially thought to be used for the photodetectors. And we can see that our new product, those windows in the 3.5 window, have high transmittance, around 95% in average. As I was saying, they are highly robust because we are only using silicon. They can be cleaned with water, alcohol, dry wipes. It doesn't matter. They don't change their spectrum. And they are also highly robust to high temperatures and corrosion, and that made them very useful, for example, for pyrometers and thermal cameras that are used in melting steel processes, for example. And what is also very, very interesting from our windows is that we have low angular dependency. So if we fix a specific wavelength, the shift that we experience, it's less than the 3%. But if we go to the competence, they are having a 15% of this in this shift. So we reduce 5 times the expected shift regarding the competence. And also we reduce less than 3 times the transmission variation in the whole range. That means if you do an integer in the whole range, we have less than 1% of transmission variation, while the competence is a little bit higher than 3%. Here we have shown the comparison with low cost and high cost competence, and we can see we have higher transmittance than the low cost. And also, what is really interesting is that we have a really flat optical response of our windows, and that makes them very suitable for those applications that you need calibration. So you don't have any problem with our windows. If you have an angular regarding the light incident, and also it is interesting because it's quite homogeneous, and you don't experience this shit, or you don't have to recalibrate your camera. And so to sum up, as I was saying, we have a highly robust mechanically, we have a high optical product that are really interesting for thermal cameras and pyrometers, also to point detectors used in non-dispersive infrared detection, gas sensing, and also for the focal plane arrays that are used inside the thermal cameras as a photodetectors. So this is all. Thank you very much.